Leaving Earth, a giant leap for humankind? Have you ever gazed at the night sky and wondered if we're alone, or if one day humans might live on another planet? The idea seemed impossible for centuries, but now, it's becoming less like science fiction and more like a future possibility. Could we humans, who evolved under Earth's blue sky, really make a home on a distant world? The answer is complicated, a mix of incredible scientific advancements and daunting challenges. For centuries, humans have explored Earth, driven by curiosity and a thirst for discovery. Now, our sights are set beyond our planet, on the vast expanse of space. But leaving Earth permanently to colonize other planets is a whole new ballgame. It requires us to overcome obstacles we've never encountered before. This journey starts with understanding the science that makes space travel possible. From the laws of motion that govern rockets to the vast distances between stars, we need to grasp the fundamentals of the cosmos to navigate it. It's about harnessing energy on a scale we've never attempted, building spacecraft that can withstand extreme conditions, and developing technologies that support human life in alien environments. But beyond the science and technology, there's a more profound question. Why should we even try to leave Earth? Is it a necessity for our survival, or an expression of our inherent desire to explore? The answers perhaps lie in our shared future among the stars. The dream of space travel starts with gravity. It's the force that holds us to Earth, but to escape its pull, we need powerful engines, rockets. Rockets work on a simple principle. They burn fuel to create hot gas that explodes out of a nozzle, propelling the rocket forward. This is Newton's third law in action. For every action, there's an equal and opposite reaction. But escaping Earth's gravity is only the first step. Space is unimaginably vast, and getting to other planets requires traveling immense distances. Even light, the fastest thing in the universe, takes time to travel through space. For example, a radio signal sent from Earth would take several minutes to reach Mars. This introduces the concept of travel time in space. A one-way trip to Mars with current technology could take 6 to 8 months. And that's just our closest neighbor. Traveling further, to planets outside our solar system, would require technology far beyond what we currently have. Despite the challenges, the quest to explore the cosmos is driven by our desire to understand our place in the universe. We yearn to answer questions that have captivated humanity for millennia. Are we alone? Are there other habitable worlds out there? The pursuit of these answers is what fuels our desire to reach for the stars. Imagine a spacecraft designed not just for a short trip to the moon, but for a months-long journey to another planet. That's the challenge facing engineers today. These spacecraft wouldn't just be vehicles, they'd be homes, protecting their crews from the dangers of space. These spaceships of the future would need to be self-sufficient, carrying everything needed for the journey. They'd need advanced life support systems to recycle air and water, as well as ways to grow food during the long voyage. And let's not forget about shielding from harmful radiation that constantly bombards space. Propulsion is another hurdle. While chemical rockets have taken us to the moon, reaching other planets in a reasonable time frame might require new technologies. Scientists are exploring concepts like ion propulsion, which uses electricity to accelerate charged particles, providing a small but continuous thrust over long durations. Building these spaceships will require collaboration on a global scale, pushing the boundaries of engineering and international cooperation. It's a massive undertaking, but the potential rewards, unlocking the secrets of the universe and ensuring humanity's long-term survival, make it a challenge worth pursuing. Section 4. Breathing, walking, and living on another world. Let's say we overcome the challenges of space travel and reach another planet. The next hurdle? Actually surviving there. Our bodies evolved to thrive in Earth's specific conditions, a comfortable atmosphere, the pull of gravity, and the abundance of liquid water. Other planets? Not so much. Take Mars, for example, a prime candidate for colonization. Its atmosphere is thin, composed mostly of carbon dioxide, making it unbreathable for humans. Its gravity is only about 38% of Earth's, which might sound fun, but long-term exposure could have negative effects on our bones and muscles. Then there's the issue of resources. Water, crucial for life as we know it, exists on Mars mostly as ice, locked beneath the surface. Growing food on another planet with different soil composition and less sunlight is another challenge altogether. Living on another planet would require adapting to these alien conditions. We'd need to create enclosed habitats with breathable air, find ways to access and utilize local resources, and potentially even genetically modify ourselves to better suit our new home. Section 5. Can we make Mars feel like home? Transforming a harsh, alien environment into a habitable place for humans might sound like science fiction, but scientists are already working on solutions. One such concept is terraforming, the idea of modifying a planet's atmosphere, temperature, and ecology to make it more Earth-like. Imagine a future where Mars has a breathable atmosphere, created perhaps by introducing specially engineered microorganisms that release oxygen. This oxygen could be trapped in the atmosphere, gradually thickening it and allowing for liquid water to exist on the surface. Terraforming is a long-term, ambitious project. It would involve manipulating a planet's natural systems on a massive scale, with potential consequences we can't fully predict. However, the idea of transforming an entire planet into a second home for humanity is an alluring prospect, driving research in fields like astrobiology, climate engineering, and planetary science. Even without terraforming, we could establish smaller, self-sufficient habitats on Mars or other planets. These habitats would need to be sealed environments, protecting inhabitants from the harsh external conditions. They'd require advanced life support systems, renewable energy sources, and efficient ways to grow food, potentially using hydroponics or other innovative agricultural techniques.